Hello, everyone. So, a couple remarks here. I would be presenting in English since I'm not so well speaking in Polish. Sorry in advance. And other remark, a lot of assumption on your knowledge of the infrastructure as a code would be made here. So, a lot of shortcuts taken because it's a huge topic. So let's begin. Hello, everyone. My name is Uladzislau Orlovskiy, and today's topic is the cool and almighty tool Terragrunt. Today we'll learn a bit about infrastructure as a code at enterprise level. My bad. So, we're going to talk about the basic caveats of the scaling infrastructure as a code to the enterprise grade level, from startups to the big companies, how we can overcome them, what we should be aware about, and how the Terragrunt can help us with such things. But first, let me introduce myself. So I'm senior DevOps engineer with a background of system administrator. I have little over 6 years of experience in IT and 9 years experience in tech overall. I have worked at the various sides of the project: startups, enterprise, some mid companies, and various domains: fintech, entertainment, media, and so on. Yeah, I don't claim I know everything about tech, but I certainly can share some knowledge. So, let's first touch base just in case. I assume you already work with infrastructure as a code in Terraform, or it can be some bash scripts or CloudFormation, some solutions from Azure. Put your hands if you have worked with infrastructure as a code. Okay, so it would be much easier. And put your hands who worked with the Terraform. Awesome. That's cool. So we can skip this slide. So here's a simple example, just in case somebody had not worked with the Terraform. Terraform works in a way that you have the JavaScript-like, it's a oversimplification, but it's JavaScript-like code that talks to the abstraction like provider, which is just a set of instructions that hits API of the cloud or GitHub or whatever the provider is working with, and provision infrastructure remotely and store information about it in some sort of state file. Again, it's an oversimplification because we have a time limit. So, and about the Terragrunt. So Terragrunt, it's literally a thin wrapper over Terraform that hides a lot of the code and abstractions in a way, so you can keep code base dry. So it execute modules in the background and hide abstractions of the providers, etc. We will talk about this stuff later a bit. So here's the structural comparison. As you can see on the as you can see on the left, it's a simple Terraform example, how it structures. Of course, you can put many things here in the module, but you anyway have to specify providers and variables and outputs and etc. But comparing to the Terragrunt, you can hide it, really hide it behind the curtains and just use a one file solution. It's like 14 lines or so for each part of the infrastructure. And you can much simpler structure the folder levels on your code base. For the context, just in case, let's touch such things as monorepositories and multi-repositories. So simply speaking, monorepo, it's just a way of working within a single repository code base. In terms of infrastructure as a code, it means that you store your all organizational infrastructure as a code in one repository, including modules. It has its own pros and cons. Yeah. And a multi-repo, of course, it's opposite. You logically divide your infrastructure by the repositories. But an example that I would show later use a multi-repo approach just in a way that modules are stored separately and we have the simple code base. It's just for simplification. Okay, so let me show the code itself. One moment, bear with me. Okay, so let me show things in terms of Terraform, and we are gonna touch as well a couple of common mistakes of building the Terraform code. As you can see, I'm purposely wrote this code in a terrible rookie way. I put a lot of hard code values just for sake of demonstration. And again, it's not a working code. It's a lot of pseudo examples. So on an example of first module, as you can see, we have a lot of hard code variables. And why hard code variables are bad? The problem with the hard code variables, it's much harder to control things around your code base. It's easier to miss something or delete a part of the code that you think that you're not needed at all. So we probably should avoid such things. And it would be much harder to scale this example. And what we can do about it? So we can use a simple abstraction of variables in the Terraform and hide it as well. Also, the cool simple tricks for the Terraform is to use counts and for each to be able to scale the solution much easier. But let me show you how it looks in a Terragrunt. That would be interesting, bear with me. So for example, here's a simple Terragrunt file that specifies the backend. The cool feature of Terragrunt, you can have the multiple files that specify backends for the Terraform states. So for example, if you have the security restrictions for the production and you cannot put the same information from the stage and the production in a same S3 bucket, you can just put state file in a subfolder and include it from different ways. So here's a simple syntax. And about the structure, I put a structure here in a way that you have the organization. It's an organization that lays in AWS account. Here's some global resources and regions. In the regions, you can put a different set of environments, for example. Oh, sorry, my bad. Here's an example that you have communal environments, QA, prod, but you can also structure that way if you don't have this much of resources. So it's pretty flexible. And speaking of, for example, for the region of US East 2, I specified completely different backend here. And also I have included the variables from the root. What it can give us. We have the locals here. And since you're including Terragrunt files from the levels above, it allows you to reuse those variables from different levels and to not repeat yourself multiple times. But regarding the remote states, it would just override the state from the level above. So pretty neat tool. And let me show you how it can provision a resource. So there is actually two ways of provisioning resources. You can store them in a monorepository and just specify path to the modules. Here's a cool feature that Terragrunt allows. You can just use a function to get a full path to the root of Git repository folder. And you just using your modules as usual. But it's not as fancy as you can see on an example here. So again, you included a state file, common variables. You can specify here a couple of your locals variables. Sorry, one moment. Yeah, and you can specify remote modules. And the cool stuff about this ability, of course, Terraform as well can use it. You can control versions, so that by multi-repo is cool. Okay, so also if you need the dependent resources, you can use resources from the different S3 state files. So for example, you can have completely different AWS account, completely different region, but you still can access information from the module, from the state file in outputs with this approach. And as you can see on the example here, I just created a replica of RDS cluster that in a different region by using the dependency from the different folder level. That actually one cool solid argument to use at Terragrunt comparing to Terraform. One of them. Yeah. And I would show you a bit more in the PowerPoint slides as well. So just a tip of the iceberg here. Okay. So back to the PowerPoint. One moment. Just a hiccup with the PowerPoint presentation. One moment. Yeah, now it's on. No, it's okay. It's just lost a bit in a way. So but before that, let's cover a bit why we are doing that at all. Imagine you have a startup company that you are working on, and suddenly all things go on really well, and you're scaling, and you need more and more infrastructure, and there's can be caveats that we should aware about. There's caveats that we can control and cannot control, as an example in a presentation. So, speaking of caveats regarding the hard-coded values, that's what can happen if you're structuring code that way. So, what we're gonna do about it? So the key things to be able to scale your infrastructure properly is to keep your code simple, not oversimplify, but just specify exactly what modules need to do, and not try to future-proof it. It's not worth it. It would overcomplicate things, and code would be less readable. And expect that your infrastructure will grow until you have solid evidence that it's not. So write your code in a way that it scales from the start. Regarding the repeatability, it's also one of the key factors that we should avoid, because a lot of refactoring efforts happen because of the repeatability of the code. How it happens? Your infrastructure scales, your modules is not refactored. Imagine you don't have any time to doing so, and you just copy-pasting things, copy-pasting code, copy-pasting hard-coded values from the part of the organization you cannot control, and it builds up. So here's a couple basic and trivial tricks that we can do. And let's talk about modules as well, because modules, even with the Terragrunt modules, would require a lot of our effort to build up and properly structure. So cool things about module, you can nest them as a Helm charts and as other stuff. So if you feel like you have a lot of modules, you can just nest them. There's no meaning to overcomplicate a single module, just nest a couple of modules for specified purposes inside and call them. Yeah, and if your infrastructure allows, in terms of security, you can use community modules. There is a lot of cool community modules of the Terraform that available. And cherry on the top, some general tips regarding the Kubernetes. So those tips actually can be implemented no matter of the size of organization. Is it startup? Is it enterprise? It not require a huge of effort. You can implement a simple code review, even if it's a 2 DevOps organization. It would eliminate a lot of common mistakes. Pre-commit hooks, actually, you can skip those if you don't feel like it, but linting is pretty cool way to avoid a lot of coding mistakes. And CI/CD, so you don't need to set manual procedures for the deploying. So back to the Terragrunt. How it can help us. So when the infrastructure as a code base grows, it's start to pretty hard to navigate through the code, especially with the Terraform, because of a lot of modules, a lot of dependencies, some rudiment folder structures. Terragrunt can keep code pretty dry, as I showed you in previous example. It's just a one file. You don't have to look in a module if you are not wanted to change. You can simply create one more Terragrunt file, reuse the same module, and at 30 lines. It allows to divide the work flexibly and to not spare your attention on details you don't need and navigate through them. And folder structuring, it's actually pretty important for the huge code bases. You can divide your infrastructure on logical levels, no matter it's regions, or it's AWS accounts, or Azure accounts, or it's GitHub organizations, and just keep much less files compared to the Terraform. And regarding backend configuration, it's as I mentioned previously, it's a key feature. You can have dependencies across multiple backends, multiple backend versions, and multiple state files divided across multiple regions. You can even have dependencies from the other GitHub repositories, but you have to use some sort of sub-module management for that. Fortunately, it's a bit of the con of Terragrunt that you cannot call natively state files from the different repositories of your organization. So, but Terragrunt has a bit of caveats, and here's some tips when consider to use this. Because you cannot simply put a Terragrunt on a small scale of a startup company and expect it to just be better, because you put a lot of effort in the learning of the Terragrunt, you put a lot of effort to set it up, and it's kind of pointless if you just need to couple EC2 instances database. Yeah, so other thing, it's a budget. Not every company has a budget to implement new things into the code base, and not all companies see the benefit in it. So if you have budget, if you have the approval, feel free to integrate. Many companies, mid and enterprise size, can benefit from this tool. But as I mentioned, Terragrunt has its caveats, because there is no such thing as a silver bullet. So Terragrunt overcomplicates infra in small scale, and it has a learning curve, as I mentioned. And if you have a lot of migration processes, for example, you had a data center, you're migrating to the cloud, importing infrastructure after the lift and shift can be tough with the Terragrunt from the start, because of the structure of the state files. And the testing of the modules also kind of tough because of the cache. You need to refresh it constantly. And last but not least, the folder manipulation, but I think it's also same for the Terraform. If you rename folder, you have the problems with the state file. It's not detecting renaming folders. And folder deletion, it simply would not natively run Terragrunt destroy and destroy infrastructure of the deleted folder, but you can simply overcome it by putting some git diff manipulation in the CI/CD, and it would be handled automatically. Yeah. Here's some memes, because I think it would be appropriate. Because of a lot of stutters, I think you might be tired of my voice, so a little pause here. Okay, so to sum up, today we're learning a bit about Terragrunt, how it can help with enterprise-grade scaling, what mistakes to avoid when you're scaling, what things to be aware of, and that not all of the tips I mentioned today can actually benefit you. So it's up to you to decide. Here's a quote of the day from me. And the last meme. So I purposely left a lot of the time for the questioning, because it would be much easier to interact with you guys and explain a lot of things I mentioned here, because it's it's a huge topic to cover. So thank you for your attention. Ask your questions, please.
Maybe a question about the future of Terraform, because Terraform, whole HashiCorp was acquired by IBM like 1-2 weeks ago, and what do you think about it? And it will change something in Terraform because it maybe becomes a paid software, for example.
It will eventually will, and I think it inevitable. It's actually Red Hat set a good example about it when they did the same thing with their Linux images. So it's kind of common. How it would affect us? It depends on the company, depends on the philosophic beliefs of the DevOps engineers, because it was open source, and you can just fork it and allow open source community to contribute to it, and it would be up to community how they would maintain that and etc. Or you can believe in a HashiCorp and IBM and use a paid version, but I would rather not. Yeah, they did. Any other question? Come on, don't be shy.
So I did not actually check whether or not Terragrunt supports OpenTofu already. Did you try it?
Come again?
Does Terragrunt supports OpenTofu?
OpenTofu?
The fork of the Terraform.
No, I believe not natively, but you can fork Terragrunt since it's open source too, for now. And actually, you can feature request it. I believe there is already feature request for that. Because these wrappers just actually run Terraform under the hood, Terraform binary.
So if we rename Terraform binary, tofu binary to Terraform and uninstall Terraform, then it should work.
Yeah, if you're using the version of the Terragrunt that still not adjusted to the changes of the new paid Terraform. You can do that.
Yeah, actually, it does support OpenTofu. The Terragrunt founder is one of the contributors.
I see. That's awesome.
Any more questions? Come on, guys, don't be shy.
I just have one question. It might be a little off the topic from the things that we have just discussed about OpenTofu and so on, but I'm recently scratching my head over how many HCL files should I have. So just to give you some example, if I have like a few modules, and those modules would be big, they would contain like resources of the some sort of, let's say, application, and I would provision everything in this module. I would version it because everything is tightly coupled. So, for example, like my service that needs an IAM role, that needs S3 bucket, and so on, versus the second approach in which we have plenty of HCL files. So plenty of modules, and we somehow split the infrastructure, for example, based on like a resource type. So we have a separate module for like one database for each role and so on. So both of those approaches have pros and cons, and I wonder what are your impressions about those?
Yeah, sorry, don't want to be that guy, but as in a job interview, it depends. So here's the thing. We can benefit from the having the dry multiple Terragrunt files by because of we can separate and have fine-grained control over the roles and stuff like that. But the cool thing about Terragrunt, you can do both ways, and it's really sometimes up to how things started in the company when they adopt Terragrunt. It depends on the security requirements, because security really want to get their hands much easier on what we are specifying in the roles, and it can be about transparency. So it's really case by case scenario. So
yeah, as you said, there is no silver bullet, right?
Yep. Yeah. So the cool thing about Terragrunt, you can do both ways. Yeah. The only caveat that you cannot overuse one module or multiple module in a single Terragrunt file. That's why it still stays dry, because it's about one module, its configuration, and that's it. You can even hide the input variables behind the YAML. It would provide also a much more dryness to it, and even just ClickOps can control it by editing YAML configuration. Yeah.
So one follow-up question about the Terraform licensing, and that's why I partially asked about support of Terragrunt with OpenTofu, because one of the thoughts why they did change the licensing with Terraform is they didn't want that strong integration in HashiCorp with Terragrunt. And in general, what's your, let's say, thought about using Terraform in general and Terraform license in the future? Did you have any analysis in your company about using Terraform with your customers into the future? Are you going to switch to paid version, or are you assuming that the license is okay to use?
To be fair, I don't. And think about the Terraform, there is one uncertainty for me because I have not followed thoroughly this topic. I still don't understand what prevents me to use the old version of the Terraform and just using the community providers, because I guess there will be free as they was, because they are not written by HashiCorp entirely, and they, as long as they didn't sneak in something in the license agreement, they cannot put their hands on.
It may force you to use the older version of some provider.
Yeah, as long as they are not duplicated in APIs of those clouds or GitHub or etc., we can use it, and it buys a lot of companies sometime. But I certainly think that big companies should investigate it as soon as possible, as soon as they have the resources to do so, because it would hurt, and hurt a lot.
Yeah, so for the moment we analyze it, and it seems that we can use it to the future, but there is always this risk that they might change something more in the licensing. And even though if you can use right now the current versions of the modules or providers, it's unsure whether or not it will be compatible in the future. So it's about, sometimes it might be a cost of rewriting the whole provisioning tool. So it's not as easy as stating that for now we can use the old version or the current version, because in the future the cost might be greater to migrate. But yeah, the general thought is that in most cases you could use it, but the question is whether or not you can use it with Terragrunt. That's the doubt.
I mean, you can. Terragrunt doesn't care about all those things. It simply create a .terragrunt folder with some sort of naming convention, .terraform folder, put your module inside and run the Terraform or OpenTofu in it, so it doesn't affect it in any way by those changes.
I mean, but you can also just use OpenTofu and don't care about licensing analysis. It's a drop-in replacement. So
yeah. And as I mentioned, you can still use Terragrunt within if you feel like.
I've got a question, because you were mentioning about integrating CI and CD in the later phase. Can you tell something about testing the Terragrunt?
The thing is, the way Terraform and Terragrunt works, you cannot test it. You can only review the plan, and you cannot even guarantee that plan would be the same on emerging. So it's about a fruitful review of the engineers, of the output of the Terragrunt plan and a variety of changes. And the cool thing about Terragrunt, since it's structured in a way that you can implement changes without a huge cascade of the plan. Yeah, so it not provides any additional benefits for testing, because you can test changes before they're gotten. Correct me if I'm wrong.
The option would be to have a separate, for example, AWS account and then do the whole.
Yeah. The cool thing about the CI/CD, so Terragrunt allows us such a feature that you can simply get the name of the environment of a variable in the locals section of the Terragrunt. You can simply get it from the environment variable and get it from file. And depending on this environment variable, you can structure conditions. So you can put abstraction to enable debugging, let's say. Let's call it debugging. And as long as your CI/CD set simple environment variables that debug is true, it would point to a completely different set of AWS accounts. And it's pretty flexible. And even the state files would change to the debug state files. So you can definitely structure something like that with the CI/CD. And you can also use it to deploy one environment set of infrastructure to a different environment based on environment variables using CI/CD. So you don't need to copy paste a folder in the Terragrunt. Yeah.